Let's get some practice in covering this FE type problem for the Civil FE and Environmental FE exam. So this is a good problem to go through. It's a relevant FE type problem. So you know the drill. Pause the video, break the problem statement down, read it slow, note what you're given, what you want to find, and do your best to start that solution. Build your own solution. If you get stuck, that's okay. That's totally normal. This is why you're watching the video solution, to see where you got stuck. And then at the point where you got stuck, pause the video solution, and see if you can move forward and finish off the solution on your own. You have to build your own problem solving abilities, and with more practice, you will do just that. Okay, we're told each person in a community produces 0.17 pounds of BOD per day in fecal waste. This waste goes into a wastewater treatment plant at an average flow rate of 25 mgd and a flow proportioned average BOD concentration of 120 milligram per liter. The average daily wastewater production per person is most nearly what? That's what we need to find. And we want to look at the units. The units are given in the answer choices. So sometimes the units are in the problem statement. Sometimes they give you the units in the answer choices. Often it's in the problem statement, but this one shows the units in the answer choices. So we know it's gallons per person per day is the final units we want to get. So now let's write what we're given as a first step and try to visualize what's going on. What's really happening here? So we know we have each person in the community produces 0.17 pounds of BOD per day. So the way I can visualize that, I'll just do a circle, and this is our community. So we can say this is our community, and we will focus on one person. So it's just one person. And this person is going to produce that BOD. BOD is the biological oxygen demand. And I want you to think of that as just waste. It's the organic matter that uses up oxygen. So the more BOD, the more oxygen we use. So it's the organic matter that needs to be broken down by the use of oxygen. So BOD is the bad stuff. It's the waste. So that BOD is going to be produced per person at that amount. So we will say this person produces that amount of BOD, and I can write it like this, 0.17 pounds of BOD. So LB means pounds of BOD per day. So that is done. We have that down. So then this waste is going to go into a wastewater treatment plant at an average flow rate of 25 mgd. So what I can do for the treatment plant, I can just denote it as a square. Let's call it WW for wastewater treatment plant. And this is going to go into this, at this wastewater treatment plant. And we will say that is going to have a flow rate of 25 mgd. So it's usually in that range, 25, 20 for these treatment plants. And we know this is actually a flow rate because it's gallons per day or million gallons per day. So that would be a Q value, and that would be 25 mgd, 25 mgd. And then it says a flow proportion average BOD concentration is 120. So here, this Q will have a respective concentration of BOD of 120. So what I can do is call that the C value, C for concentration. So let's call that C of concentration of 120 milligram per liter. Milligram per liter, just a heads up, it's also a part per million. 1 milligram per liter is a part per million. So now that is done, this is done, and then the final goal is to find the average daily wastewater production per person. That's what we want to find. So let me denote that at the side. It's going to be essentially the units here of gallons per person per day. Gallons per person per day. So now let me go into the solution and ask you this question. If we have the ultimate goal is to get these units on the right, gallon per person per day, what would you say is going to be the overall goal, or what would you take divided by what, or what would you multiply by what? So when I see these units, especially for these water resources problems, we know a gallon per day is what? It's a Q value, it's a flow rate. So we can write down the side, Q is going to be a gallon per day because it's volume per time. That's a flow rate. So I need a flow rate somehow. This portion is a flow rate. Then I need to take that flow rate and put something on the bottom. What do we put on the bottom? The persons, the people, the population. So what we're doing at the end is taking a flow rate divided by a population. And that would actually give us the average daily wastewater production per person. And that production is going to go into the wastewater treatment plant. So that's what we're doing at the very end. And we'll show that in the calculations. But before that, there's some tricky parts we have to remember. Mainly, the first thing we have to do is actually quantify the total amount in pounds per day of BOD that goes into the wastewater treatment plant. And we can do that. And I want you to remember this. This part is important. That if you're given a flow rate, which is an MGD in this case, those are the good units. That's what we want in US or imperial units, 25 MGD million gallon per day. If you're given that, and you're also given a concentration, you can use something called the loading formula to get your amount of pound per day of waste, sludge, BOD, suspended solid, whatever it may be, the solid portion in pound per day. And it's very convenient when we look at US units, the units you will see on your FE exam. So what we will say first is to find the total pound per day that goes into the treatment plant, this wastewater treatment plant. So what I'm going to say as step one is to find the loading, essentially the loading of BOD in pounds per day. That's what we will do first. So now you might be asking, how would I do that? We do that using a loading formula. And just a heads up, this is in the FE handbook under the environmental section. We often use this for wastewater, water resources, mainly wastewater and water treatment analysis. So we know the formula goes as follows. The pound per day is going to equal to our Q value, which is going to be in units of MGD. So the units here have to be these units. So the Q value we take has to be in MGD. We multiply that by the concentration. What does that have to be? In milligram per liter, it must be. 1 milligram per liter is a part per million. So if you use both of those, you'll be okay. Then the last one is going to be times 8.34. And this 8.34 is actually 8.34 pounds in 1 gallon of water. So 1 gallon of water is going to weigh about 8.34 pounds. This is under unit conversions in the FE handbook at the very beginning on page 3 or 4 if you're interested in that. But that's a conversion for water. So now, just a heads up, this equation is in the FE handbook and it's under mass calculations. Calculations in the FE handbook. So if you search this key term in the environmental section, you'll see it. You'll see something similar to this. And the units have to be these. So plugging in some numbers, we know it's the pound per day of BOD. So let me denote that as BOD. And that equals to the Q. The Q value is given to be 25 MGD. Those are the units we need to have. C is going to be 120. That's given in the problem statement, milligram per liter. Then we multiply by 8.34. So you may be curious, okay, these units don't look alike. How on earth do they cancel? They do cancel. So we can prove that real quick just to answer your question there. You should always get pound per day, but let's prove that. So we know it's MGD. MGD means what? MGD is million gallon per day. The day goes on the bottom. Okay, those are those units. Now, the milligram per liter is the trickiest part. A milligram per liter is always a part per million, which also says it's a 1 milligram per million milligram, per 1 million milligram, or 10 to the 6 milligram, because it's a part per million. The part is 1 milligram. The million is going to be that unit, which is the milligram. 10 to the power 6, 1 million milligram. And lastly, this translates to something in pounds. We can do this. A milligram per liter is a part per million, and it's going to be 1 pound. 1 pound per what? That same unit, but it's a million at the bottom, which is going to be 1 million pounds. So we can call it like this, 1 m per million. I'm going to write it like that, and we put pounds. 1 pound per 1 million pound it's still a part per million, and it's still milligram per liter. These all are the same. So this, we can say that milligram per liter is 1 pound per 1 million pound. And let me do this, multiply this by pound per gallon. That you don't mess with. Now notice what happens. The gallons cancel, the M part cancel, the million, and we have the pounds cancel, and at the end we get pound per day. That's what we have. So now let's do that calculation. Do it with me in your calculator. We take 25 times 120 times 8.34. We get about 250.20. So that would be the pound per day of BOD that goes into that treatment plant in total. So it's going to be 250.20 pound per day. So now using this, we can actually find the total population as the next step. So that may be a question on itself, find the total population. And we're going to use this conversion because we know one person produces 0.17 pound of BOD per person per day. So that's for one person. So what we can do is actually write it like this and denote the person at the bottom. So now based on this value, we can cancel units and find the total amount of persons or the total population. So that would be the second step. So we can say step 2 is find the total population in community. Population, or this is also the persons. Persons, population, people, same thing. Capita, all mean the same thing. So what we would do is play with the units. So essentially we're gonna take the 0.17 and take this value divided by the 0.17. So the total persons or that population is going to equal to the 250.20 pound per day. This is the total that goes into the plant. Then we take this divided at the bottom by 0.17 pound of BOD. All of this is BOD per person, and that would be per day. Now look at the units. These cancel and the pounds cancel, and we get just units of persons or the total population. So doing that, we take the last value we got divided by the 0.17, and we should get about 147,176. Let's just put 0.47 persons or people or capita. This is the total population. So again, that might be a question on its own. So now the last step is to find the goal is gallon per day per person. So what we can do is take our 25 MGD, because we know that doesn't change. That's the total flow rate, the average flow rate that goes into the plant. So I can take that and convert it to gallons per day. I'll take care of the million. Then I divide by the total population, which is the persons. And then we get the average daily wastewater production per person. Let me show you how we would do that. So what we would do is find average daily wastewater in production. Let's call this production in units of gallon per person or per capita per day. And what we would do is take the flow on the top and then we divide by the total population. So what I would do is take the average daily, let's call it just average daily, and that would equal to the gallons. So that is the 25. So we take that on the top. So we take 25, but no, it has to be in gallons per day. So I take 25 times 10 to the 6 to take care of that million part, the M part. And then that would give me gallons per day. Then just know you would do this and divide out by the total persons, which is 147,176.47 persons. Now doing our calculation, we take the 25e to the 6, and you take this divided by the 147.176. So doing that, we get about a value of 169.86 gallon per person. And then at the bottom, it's going to be per day. And that we would round up to about the 170 gallon, let's call it P per person per day. And that would be the answer. So this is the daily production in wastewater that goes into that plant per person and gallons per day per person. So it should be D for that one. Now let's finish this off by showing you the fast method to do this. So I didn't show that too early because I want to break down these steps starting from the basics, especially if you're seeing this for the first time. So that loading formula is important, know how to use it, but now we can actually go a lot faster and do this. So we know the original loading formula is pound per day is going to equal to the Q value, and we multiply that by C times 8.34. So Q has to be million gallon per day, C has to be milligram per liter. So now we can change this up a little bit. We can say it's pound per person, and we can put the day portion, it's still there. This pound per day is still there, so that's good. Then we say the Q value multiplied by C multiplied by 8.34. Why this is important? Because we can take the pound per person per day value that we're given, which is 0.17. So what that means is I can take 0.17 pound per person per day, and I still have that pound per day, but now that person is going to be at the bottom. We're not going to touch that. That's fine. Let's keep it there. Then we do Q. Don't touch Q. That's actually what we're finding. We're finding that Q. When we find that Q, we're finding the 170. We're finding the gallon per person per day at the end, because it's a Q, it's a flow. At the end, we have the persons as the units at the bottom though. So that Q is what we want to find, and that would be the Q average for each person. We multiply by C. The C value is the concentration of BOD, so that doesn't change. It's going to be the 120 milligram per liter. Multiply this by 8.34. Then we solve for Q average. So notice, we solve for Q average, but what units will you get? For this formula, this Q average is always million gallon per day. So those are the units we should get. So do this with me. You take 0.17 divided by the 120 divided by the 8.34 at the bottom. So the 120 and 8.34 is going to be at the bottom. So 0.17 divided by those two values, we get about a value of 1.69 times 10 to the negative 4. Or you can write it like this, 0.00169. So this gives us as million gallon per day. And now, don't forget, there's still that person part at the bottom, per person, the bottom portion. But then that million is times 10 to the 6. So what I can do is just take this value, multiply it by a million, or times 10 to the power of 6, and we get gallon per person per day. So taking this value times 10 to the 6, we get about 169.86, which is close to that 170 that we got. And all of this we did just in one step. So know how to do this, know how to break this down from the basics, know how to find the total population. That might be a question on its own, and at the end do it a little faster by trying to apply this approach. That's all for this. Thank you for practicing with me today. Please comment below if you found this helpful, and if you have any questions, just let me know in the comments below. Like this video, and don't forget to subscribe for more videos like this. I'll see you in the next one.